Hello, and welcome to my screencast on the topic The Chemistry of Space. My area of focus is going to be to answer the question, is there evidence for life on Mars? And the answer to that question is yes, there is. The branch of study that I'm going to be talking about is astrochemistry, and astrochemistry is quite simply the study of chemistry in outer space. But more specifically, it's the study of the chemical elements, ions, and molecules, and the interactions that they have each other in space, as well as interactions with radiation in space. For this presentation, astrochemistry is going to be applied to give possible theories of possible life on Mars. What do you already know about Mars? Well, Mars is a planet in our solar system. It is known as the red planet and has 2 moons. The composition of gases in Mars's atmosphere is said to be pretty much mostly carbon dioxide and some water vapor. Carbon dioxide is about 95% worth, and some water vapor. It is 142 million miles away from the Sun. It is the 4th planet in our solar system out from the Sun, and Earth, which is 3rd from the Sun, and Jupiter, which is 5th from the Sun, are its neighbouring planets. Its diameter is just under half of that of the Earth. Some more facts include the length of the day, which is 24 hours and 37 minutes. To help us answer the question, we're going to look back at the theories of how life began on Earth. There is evidence on Earth that living things did exist on Earth approximately 3,500 million years ago. However, no one was there to record how life began. And yeah, early Earth's atmosphere was said to have consisted mostly of carbon dioxide, although other gases were present in small amounts, and these gases include ammonia and methane. The main theory is that living things developed from molecules, in particular organic molecules that could replicate, or in other words, copy themselves. Over millions of years, these molecules joined with more and more molecules, becoming gradually more complex and dependent on each other. What I'm basically trying to get at here is that the more, inorganic and organic molecules that are present, they're more likely to have some kind of interactions, and then this could potentially be a theory of how life started, which is the theory of how life began on Earth, and could be the similar for Mars. Why we think there could be life on Mars was thanks to NASA's space rover, also known as Curiosity, that's what it looks like right there. And the evidence that it gave us is simply it discovered methane, and it on the 16th of December there were many news articles on the fact that Curiosity had discovered methane. And methane is a gas that's produced by living organisms on Earth, both past and present. It has been discovered by Curiosity, which is suggesting that there is potential life that could be producing this gas. And some of these include microbes and rocks, and microbes are considered to be living organisms, so there is actually life on Mars, is what NASA is saying after their discovery from Curiosity. And this is a summary of where this discovered methane came from. Methane can be generated by microbes, and can also be generated by processes that do not require life, such as reactions with rock and water, producing methane. What else? There is also UV radiation can interact with this methane after it's been produced, and can form more inorganic and organic molecules which can replicate potentially. Further evidence and explanation: methane is quoted to be a reduced gas, which means the atmosphere is all on Mars. Having the atmosphere on Mars is always oxidizing, and therefore methane shouldn't exist if it continues to oxidize. But methane is somehow still present after all these years, and therefore it is suggesting that there may very well be life on planet Mars. Alternative possible theories that liquid water, according to the Daily Mail, has been found, few hours every day in the spring and summer. Not clear evidence has been provided, but they think that according to scientists, they've reported there could be liquid water, which if this water in general, if it interacts with the surfaces of Mars, it triggers more methane into the atmosphere. Conclusions and comparisons. Before Earth produced life, it consisted mostly of carbon dioxide. Mars in the present day contains mostly carbon dioxide today, right now. So is this a similar trend? So we're going to see life in couple hundred years to come? Who knows? The main theory is that living things developed from molecules that could replicate. So if the levels of the molecules methane, water, carbon dioxide were to increase, this increases chances of replication as quoted. And just in general, what I've been trying to get at is this whole PowerPoint, what I've been trying to get at is methane is a clear sign of life, because with, if what else could be producing it? If nothing was producing methane, it would have all been oxidized and turned into carbon dioxide. So that, a couple months ago, methane was discovered, so there's still some remaining. And finally, methane is an organic molecule, and therefore by reactions with UV light, increased number of organic molecules will form, increasing the chances of replication. So simply more molecules, more chance of replication, more chance of life. Thank you for listening.